Welcome back to VTU e-Shikshana program on computer aided engineering drawing. We are in module 3. We are discussing about the sections of solids and the development of surfaces. We have dealt with the solids like the square prism, square pyramid. Now we will discuss rectangular prism and the pentagonal prisms in detail. For example, whenever you get a problem in development, the basic position is important. So, for example, we have the solid which is placed on HP. The questions will be like this: the base on HP is inclined at some degree to base edge on HP is inclined some degree to VP. Say for example, longer base edge or smaller base edge, or you will refer to the lateral face. In this case, larger lateral face, larger rectangular face or smaller rectangular face on ground. In case of pentagonal prisms, a lateral face is inclined at some degree to VP. It may be nearer to VP or away from VP. Normally we take nearer to VP by default. Okay, or one of the base edge is inclined 30 degree to VP is nothing but one of the lateral face having that particular edge is inclined at 30 degree to VP. Let me take 2 to 3 problems in this session to discuss that type of problems. We have a rectangular prism of base 40 mm by 25 mm and height 65 mm has its base on HP such that larger lateral face is inclined at 30 degree to VP. It is cut by a section plane inclined at 40 degree to HP and bisecting the axis. Draw the development of lateral face of the remaining portion of the solid. Normally, majority of the prisms you get the lateral face of remaining solid. In case of pyramids only, sometimes they may ask you to work out the development of portion containing the apex. We will discuss that in later stages. Now let me take this particular case. This is HP, this rectangular face, and there are two larger lateral faces, 1, 2. This is smaller lateral face. Here assume that this is VP for you and here is the surface, and the surface is right now parallel to VP. Now it is inclined at 30 degree to VP. Actually this is VP HP condition, VP HP, and this is standard position. Two larger base edges or larger lateral face parallel to VP, or one of the lateral faces parallel to VP, or this can be the situation. So here this is also 30, naturally the one which is backside of this is also 30. So in this situation you have to start working the problem. So how exactly you start? So by default, let me take the inclination of the larger base side this way, so that you will get the rectangular, one of the side is on HP, completely base is on HP and one of the lateral face is inclined at some degree to VP. So let me draw that. So you know how to draw the rectangle. So in one go you can dark in case of solids, projection of solids. Here development, normally we take the first position or the top view or whatever the front view with light lines, because once you draw the section plane, the portions may be retained or removed to be considered. Then you have to maintain the one which is to be retained with dark line and the one which is to be removed with light line only. Now dimensioning as usual, draw this. This is 40 and this one is 25. See that whenever there is an inclination, this side you must keep this up. Normally if it is vertical, then only we keep to the left, otherwise it is vertical. Now name these points: A, This is A, this one is B, this is C. So why I have taken this only? This is left extreme, nearest corner to the observer. Normally we take that and give inclination to this, say inclination. So this is how you draw the first figure top view. Next, projection of the same onto the VP, front view area, that is first figure front view. Here the only one position, next is only the development, unlike the projection of solids or laminae. Assume that this is the height. All are light lines. I am keeping all are light lines. Now let us decide whether which one to be dark. Concept of visibility here. This is A1 dash, A dash, B1 dash, B dash, C1 dash, C dash, D1 dash, D dash. Why I am keeping this in bracket? Because it is not visible. Suppose that you keep it like this: A, B, C, D. A, B, C are visible, not D. In this case also, case of solid, you can say A1, B1, C1. D1 is not visible. And also A, B, C, D is not visible. Now, keep the axis reference. It's very important. Since he has given bisecting the axis. This is O dash, O1 dash. Next, lateral face inclined 30 degree to VP. That we have satisfied. It is cut by section plane inclined at some degree to HP and bisecting the axis. So in that case, you identify the midpoint of the axis and draw section plane. So if you draw section plane inclined 40 degree, assume that taking 40 degree, hyphen, full line hyphen, so you see that it is a single plane. In computer, you can easily draw, use collinear and also parallel references. Is it dark at the ends manually for working, and then keep arrows. This refers to retain the portion below this arrow section plane. That means from this point to this boundary again to this, and whatever the retained lateral edges must be in dark line, dotted line or visible line must be in 0.5 in case of computer. Otherwise, you make it HB pencil here. Dark line, thick line. Now, before going to dark this, identify the intersection points. So in case of the pyramids and prisms, whatever we have discussed last class, suppose that this is the section plane for a square prism. What we did, assume that this is the second plane, this is the intersection plane, 1, 2, 3, 4. This is the portion to be removed after taking section, this only is retained. This is 1. This is intersecting the longer edge A1 at 1, longer edge BB1 at 2. Like that, only we have to work here. So, A1 is intersecting at 0.1 dash I say here. BB1 is intersecting at 0.2. This is also visible. A1 is visible, BB1 is visible. CC1 is also visible because that is the extreme edge, 3 dash. Whereas DD1 is not visible. So that should be made dotted. So let me keep this should be made dotted. Because overall it's not visible. Yes. Even this thin line, it should be dotted. Invisible edge. Now, after naming visible edges, intersection points, you name the invisible edge in bracket. Any more points? No. Only 4 lateral edges, all lateral edges are intersecting with the section plane gives you 4 intersecting points, 1 dash, 2 dash, 3 dash, 4 dash. So that actually coincides with corners only. You need not have to name it unless situation demands. If you need that particular top view details, then only you project it, otherwise no. Now dark all the remaining portion of the solid. This is must. Otherwise, you commit mistakes. This is what you have to develop. Whatever the remaining portion of this solid surface, lateral surface, you have to develop it. Okay, this is about the top and front views of the given solid with the given orientation, then fixing the section plane, and also identifying the remaining portion. Now, how to draw the development? So, development is already we have discussed. Parallel line method. All prisms should be worked out with parallel line method. Okay. Now, identify the starting point. So, this is xy. The restriction for xy space is only this. From here, development starts. Now, I have to start from AA1 edge. So, keep this as A1. Otherwise, simply ABCD you can keep. You can recall this is longer edge A, longer edge B, longer edge C. You can name like that. But better you keep AA1. Now, it must be very carefully done. AB is 25. BC is 40. Alternately, it will change. Now, you will have the the distances. Say this is 40 and this one is 25. So, you take care of this particular item. Otherwise, it will lead to the problem. Now, first A to B is 25. B to C is 40. Again, A to B is 25. B to E is 40. Okay, assume that I have extended up to this. Now, carefully aim this B1, this is C1, this is D1, this is again A1. Now, check twice. 25 to start with, A to B is 25, B to C is 40, 25, 40. Yes. Now, draw vertical lines because representing the longer edges of the prism. Suppose that there is no intersection plane is there and complete lateral surface you are working, then this is the solution. The lateral surface of the rectangular prism. Now we have to go for this section plane. It's a very easy job. Parallel line method. You draw parallel lines to towards the development on the respective longer edges. You get the intersection point. This is B. This is C. This one is D. This is again A. AA1, AA1. Once you close it, you will get the same. Now start with 1. You have 2 lines AA1, AA1. You have to draw up to that. Draw projection mean the line, projection line of that particular intersection point up to this. Here you get 1, here also 1. Then 2 at only one point, BB1, up to B you project. Yeah, this is 2. Next comes 3 in sequence, that is on CC1. This is 3. Next comes 4, DD1. We have 4 intersection points with 4 longer edges. Now join all these intersection points with the longer edges with the dark line only. You will get the corresponding top profile of the development. Yes. Then boundary as usual. Then what about these lines 2 to B, 3 to C1 and 4 to D1? All must be dark because they are actual edges. They are retained after taking section and the development. All are true lengths. Now naming and dimensioning of this is to be done carefully. This is 25, this is 40, then overall development, this length is capital L, yeah. So 65 plus 65, it is 130, L equal to 130. So this is how we can work out manually, neatly represent the dimensions, arrows, etc. Now let me see what are left. So we have done this complete development with 25, 40, 24 alternately and named all the intersection points and darkened the remaining portion of the solid including all edges. So that's all about the final solution of the lateral portion of the remaining portion of the prism. Okay. Now let me take next problem, that is on pentagon. The pentagonal prism of 30 mm base edges and height 60 mm rests with its base on HP, such that the lateral face is perpendicular to VP. It is cut by a section plane inclined at 45 degree to HP and passing the top right corner of the solid. Draw the development of the remaining portion of the solid. Last session we have discussed about the square prism. It says there it's passing through the top right edge. Here I am keeping corner because you will get the corner there. Once in case of pentagon, odd number of sides, one side it is edge, definitely the opposite side will be the corner. Okay. So naturally the it should be corner. Okay. No, that's why it is given. Otherwise, we may say it is passing through the top, extreme top portion of the solid. Normally they will give specific thing. Okay. Now let me work out that problem. So before taking that particular problem, let me take the model and explain. Here, unlike the solids, the axis inclined to HP, axis inclined to EP, etc., and you will give different positions in the development problems, you will be specific to a particular orientation. Then you will give cutting section plane. Okay. Now this particular edge is perpendicular to VP. Okay. So you can ask me, why not you take to the right side? Yes, definitely you can take to the right side. Normally by default we will take to the left side and start working. Okay. Now this particular orientation works for the given problem. See, he says lateral face, one of the lateral face, this particular lateral face is perpendicular to, okay, now I will take the plane, okay, perpendicular to it, and I will place one surface, lateral face. Now you can say clearly the particular lateral face is perpendicular to EP, or they may give, instead of giving lateral face is perpendicular to EP, or they may say one of the base edges is perpendicular to VP. Naturally the corresponding associated lateral face is perpendicular to VP. Now in this position you have to draw the figure, top view, front view, then consider the section plane. So I will repeat, this is the orientation. You must keep this line perpendicular to VP and start working. So here is the very important information. Whenever you have pentagon, so you must be very careful. Take the perpendicular line. On that you mark the side of the pentagon and then keep 108 degrees, 108 degrees line, and then take same radius and draw arcs. Then again keep this, take this distance only and draw arcs. Okay. Now join this with the light lines only. Then we can dark. Otherwise, you need not worry about the top view. Dark line, thin line, etc. Let it be thin line only. Okay. Now, if condition necessitates, then only you start working dark line, thin line. That is only in case of section of solids. Now, this is A, B, C, D, E. Start A here, B, C, D, E. Now, identify the center, because whenever you get solids, you always prefer to refer solids. Center O1. Okay. Now, again I am telling you, this is very important. One of the lateral face or one of the base edge is perpendicular to EP. Then get the corresponding front view. See that B1, BD are coinciding each other. Identify the height and draw the projections. Okay. Now, so this is A1, A1 dash, A dash, E dash, E1 dash in bracket, because A1 is visible here, and B next, B1 dash, B dash visible, then C1 dash, C dash visible. Just behind B we have D, D dash, D1 dash. Then this is axis O dash, O1 dash. It's imaginary line which very much necessary for all solids. Now he says the section plane is inclined 45 degree THP and passing through the top right corner of the solid. So definitely it must pass through this. See here the left one is basically edge, because we have associated base edge on HP. This is the edge, and right side we have corner. This is the standard position, so that you will get this particular item, that is corner, top corner. You take the section plane passing through this. That's what he refers to, passing through the right top corner. Now let me draw a line inclined at 45 degree passing through that. Now 45 degree line, section plane representation. In computer we have third line as the reference in the box. You can take it. Now here is the reference. Remaining portion of the solid. It is entire longer edge is available. Here BB1 and DD1 portion of the longer edge is retained. BB1 is visible, DD1 is not visible. And again I hope here also we get some value. Now here definitely you must identify the axis inclined 40 degree to HP. Okay. So here again 40 degree to HP. Sometimes they will give angle of inclination with respect to axis. You must be very careful. Here again 45 degree to HP. You can dimension outside or inside, no problem. 45 degree to HP. Okay. Now normally we miss this line. Okay, that is baseline. It is retained. Okay, let me review whatever is available. A, B, C, D is the top view. Naming A1, B1, C1, D1 is there, but we normally never identify here AA1, BB1, CC1, DD1, EE1, and we have taken section and we have made dark lines for the remaining portion of the solid, and this is the reference for us. Process through this. Now, how to draw the development? Overall development, let us draw first. As in previous case, we had two lines of different sizes. Here, equal size. Okay, all are equal. Now, assume that we have the parallel lines method should be used. Now, start with a line. Then take compass and work with the, assume that I am using compass and drawing arcs, number of arcs, 4, 5. Take distance, whatever given is 30 and height is 60. Okay. So, height of the development is 60 mm, definitely draw parallel. Then start naming A1, B1, C1, D1, E1, A1. Okay. XY will be limited to this portion only. Normally we draw continuous line and then fix, but you see that XY is restricted to only this. This starts development. Now start working with the vertical lines representing the edges of the prism. All are equal size. Distance is same. Now you identify this one and the last one. This is 30 and overall development length is L equal to 150. Prefer mid portion just above the line, you try to give legend. So you might have observed all the time I prefer to have the mid portion, and that is the convention we have. Now keep AA1, BB1, CC1 for all clarity purpose. You can keep only ABCD, no problem, but better to have clarity. The longer edges are ready, overall development is ready. Now start working, projecting all the points. So twice you have, definitely you must project up to this and mark these two. Next comes this one. Let me name first. 1 dash, 2 dash, 3 dash, 4 dash. Because only one point is there. Here there are 2 points. Here there are 2 points. A1 and E1. 5 dash. 1, 2, 3, 4, 5. Then as usual project these points. So this must be projected on B and D, up to B and D. Here is the point, here is the point. Next 3 is this only. Okay, now let me name, this is 1, this is 2, this one is 3. 1 on AA1, 2 on BB1, 3 on CC1, that is occupying this top point only, C. CC1, I have C as the top point, that only is the 3. Then 4, considering with 2 in front U and same height will be maintained. And 5 is as per this. So this is 5, this is 1. Now join the development profile here, cut portion, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 1. Then draw the overall development boundary, dark, it must be always dark line, and see that any more lines are to be darkened. Yes, we have left with 2B1 complete edge available, CC1 with the 3S, the top point, and 4D1, 5E1. So don't forget this, it is as good as the important edges of the given problem. Now, this is how you complete the solution for the development of surfaces. Suppose that this particular edge is parallel to VP. Instead of perpendicular to VP, parallel to VP will give. Then how to solve? And at the same time, this particular section plane, all the time, whatever we have worked out so far, now are intersecting the longer edges only, or at the most that is touching the top point, or in between, see, in between, or in between here. Okay. Sometimes it may cut this. Suppose that this is the section plane. This is the section plane like this. Then what happens? Now, this particular edge length is apparent length. Whatever is available is on the top view is true length. That we had such problems in the previous session for square prisms. Now, next we will work that type of the problems. Before that, let me take this how to work on the computer. So, let me take a problem on rectangular prism of base 40 mm by 25 mm, the height 65 mm, let's with its base on HP, such that a larger face is inclined at 30 degree to VP. It is cut by a section plane inclined at 40 degree to HP, bisecting the axis. Draw the development of the lateral face of the remaining portion of the prism. Now, you know how to draw the projection of a solid with a given condition. This particular line, see, this particular line is representing a lateral face that I have taken 30 degree. So, normally in case of projection of solids, we have longer edge or the shorter edge perpendicular to VP and process. Okay. In this case, he has given very clearly one of the lateral faces inclined at 30 degree to VP. Or he may give the same problem, one of the longer faces is inclined at 30 degree to VP. Is as good as giving the lateral face is inclined at 30 degree, because that particular longer edge is associated with the lateral face which is vertical and inclined at 30 degree. Okay. Now, so after drawing the top view with this one of the line longer base side 30 degree, then complete the rectangle. This gets you, this represents the top view of the rectangle with given size 40, 25. Next, project it up and get for the given height 65 mm. So, with all the values, we have AA1, BB1, CC1, DD1. Okay. With all prime because of front view. Now, this is the axis. Now, how to draw the development of the overall development you must complete. So, you use offset. Now, overall length you check, that must be 130. See, 130. Now, we can start working. This is very important, overall development. Now, after drawing this, you keep A1, B1, C1, D1, A1 again 1, 2, 3, 4, 5. So, start working. Then you project, you fix the section plane. How to fix the section plane? The section plane is passing through the point, then draw the line. You know how to draw it with the convention available. Then, assuming that the development is ready with A1, B1, etc. with all these dimensions, then you project all these section points 1, 2, 3, 4. Okay, so how you identified 1, 2, 3, 4? As I explained earlier, visible point 1 is on AA1, next visible edge is BB1, that is 2. DD1 is not visible, even though it comes after 2 before 3. It's not visible. Visible edges first 3. Next, invisible edge DD1 with the corresponding intersection point is 4. Now you project all these points onto the development. Now you get these points 1, 2, 3, 4, 1. Then join all these. Okay. So this is the development. That is what I got in the manual working. Sometimes what people do is in a hurry or by ignorance, they take continuously all 25 or continuously all 40. That is wrong. See, I have seen such answers. See, all 25 there, even though 25, 40, 25, 40 is there, all 25 there. I have marked this red line for wrong thing. Okay, this is wrong. And again, one more thing is they take all 40. Again, instead of 25, 25, they take all 40 and complete. But you get some, answer, but it is not correct. So in computer, you give garbage input and get garbage output. Here also same thing you get. Everything is very nice to look at, but the answer is wrong. So here is the correct answer. Alternately, you get 25, 40 as per the requirement. You start from this, first is 25, then 40, then this is C to D is 25, again this. Why I am insisting? Majority of the time I got that answers. Okay. Now this is about the rectangular prism. Now let me shift to pentagonal prism. So there simple problems I worked, and I will just check whether the alternate problems are there or same type of problems are there. Then again pentagonal prisms, yes. See here I got same problem. Now you know the problem is a pentagonal prism of 30 mm base edges and height 50, and this may vary. That all depends. Okay, all depends on the question. It may be 60, 40, suitably they give with its base on HP such that a lateral face is perpendicular to VP. It is cut by a section plane inclined at 50 degree to the axis. It's very important. Instead of giving inclination to the HP, they will give 50 degree to the axis. Normally what people take is 50 degree to the HP only they take. That is wrong, because whatever is given is 50 to the axis. You just check twice whether it is given to the axis or HP. You convert that into axis HP and do it conveniently. Otherwise, to the axis only you take with the protractor and do it, or with the computer you are working, you see that with the axis it is 40. So check twice whether it is given for the axis or to the HP. And passing through the top right corner of the solid. This is actually, the left one is the edge you have fixed as per the requirement of the orientation. Then this is naturally corner. Okay. Suppose that this is hexagon. Then this is edge means here also you get edge. Okay. So here it is pentagon, odd number of sides, you get corner. Now it must be corner only. So you see that this is passing through the corner and possess 50 degree with the axis or 40 degree with the, then you know how to draw the development. Offset method. Here it is 30, and not chain, it is normal, single, single, and then select this, see that it is single, and select single, and if once you click this, you will get accept, yes, accept. Then you come here, this side, yes, this side, this side, yeah. See that it is single, not the chain. 1, 2, 3, 4, 5, 6. You can do 6. If you want to keep the right click, do 6, and then say keep one off. 1, 2, 3, 4, 5. Then if you don't want this one, you can block that and then remove. That's all. Okay. Now this is how you can do that. Even rectangle you can do there. Now this is the naming of the development, overall development. Then keep this projected, and this is the key point 3, touching the top point. Then have the points joined. Then normally they end with this as final answer. No, you have to draw lines. Then keep the final answer. This is how you can complete the thing. Now suppose that this particular angle is different. Now how exactly you can do it? So it says the side is parallel. One of the side is parallel instead of perpendicular, and in 10 mm in front of VP they give. So definitely you must take that parallel to VP and 10 mm. Actually one of the lateral face is parallel to VP instead of perpendicular here. Here it is parallel. There also same thing you have to follow, same procedure. Passes through the top corner inclined at 50 degree to the axis. Okay. Then draw the development and then keep this projected and join the pattern, you will get this. Okay. This is how you get the indifferent orientation. Now, we will take up this particular figure and discuss how exactly this particular lateral face is parallel to VP with this particular problem. See, this one is rectangular face. Here I can show you ED, D1, E1 is actually parallel to VP. That is what I wanted to expose from this. So we can use this figure to realize the rectangular face ED, D1, E1 is parallel to VP. So that is what the basic problem, basic condition of this particular problem. Okay. See, he says space on the HP and the lateral face is 10 mm in front of you are parallel to VP. So then you know the section plane and all will come. Then we will see some advanced problem of this pentagonal prism. We will work out manually and then work with the computer.